to call this reduction. Oxymercuration and demercuration are reduction. Which is the oxymercuration part? You use mercury. Mercury what?
Oxoacetic.
2 plus, yeah. 2 plus.
Oxoacetic.
No, O,
OAC.
yeah. OAC.
Acetate.
Yeah.
Two of these. The oxidation number on this mercury is
Plus two.
+2. That's that part, and this part is sodium borohydride.
Hydride.
Okay, that is the reduction part. The hydride part is the source of H minus. Okay. All right. So when we do this oxymercuration, demercuration, what type of product do we get? We get an alcohol from here, and this alcohol will be what? Tell me about oxymercuration, demercuration. Marie? Where's Marie? You guys are not going to talk this much, yes? This week? It follows Markovnikov addition. Markovnikov addition. So, does this follow Markovnikov addition as I have it here right now? No, as
No.
I have it here right now, it's no Markovnikov addition. If I put a CH3 here and a CH3 here and an H here, does this follow Markovnikov addition? Means that the OH is going to go where?
No, same.
Where is the OH going to go?
On the other side.
Here?
No.
No.
The OH is going to go here. Markovnikov addition says that the H is going to go where?
To the less hydrogen.
And more functional group.
Where there is more hydrogen. So this is going to look, there's a hydrogen here, another hydrogen there, and the OH will be here, like that, yes? That does not show you stereochemistry, it doesn't show you anything, okay? Yes or no? Let's say, and I do not want you to show me stereochemistry. In the first step, we're going to add mercury acetate. Second step, sodium borohydride. Provide the product for this. What's the product?
Alcohol will be on the top.
Where?
On the top.
Where does the alcohol go in?
Top. Right here.
It goes there.
Yep.
Yes?
Yep.
That is called Markovnikov addition. If I were to do the same thing, but this time instead of oxymercuration, demercuration, what we do is hydroboration. The other part is oxidation, no, hydroboration oxidation with BH3 and H2O2.
And two
Oh,
or
and
two.
then OH.
Yeah.
Provide the product for that.
Okay.
What you have to know from here is that this is
Anti-Markovnikov.
But they don't like to say anti, yes? Because anti-Markovnikov gets you confused. They like to say non-Markovnikov. Okay? So whatever. So let's write here Markovnikov. And here,
Excuse me.
so if this is non-Markovnikov, it means that the hydrogen is going to add where?
On top.
Until the one with
With
more
More
substitute.
substitute.
So it will add here, the OH will add
Down there.
to this side.
Yep.
Yes or no?
Mhm.
Outstanding. Now, as far as, okay, let's do the mechanism for this. This is not going to be a complete mechanism. This is going to be parts of a mechanism. Okay? So in the first part, we have this mercury. With the acetate
Mhm.
and with the acetate, yes? And what is going to happen is
The bond.
The bond is gonna go to the oxygen.
the acetate is gonna go that way.
Yeah.
And this mercury is going to have what type of charge now?
Plus.
Plus.
It's going to have a plus, yes? If you took the electrons from it, it will have a plus charge. Yes? Now, this plus charge is what? Is it an electrophile or a nucleophile?
Electrophile.
It's an electrophile because it has a positive charge. Now, we do have a carbon-carbon double bond. And the carbon-carbon double bond, like we have shown before, which was an H plus, yes? And the double bond attacked the H plus. Now this is going to do what?
Attack the mercury.
Attack
Like
the
the
Mercury.
mercury.
mercury. Okay? That's it. This is not that difficult.
Yep.
So let's say that what I have is, let's not put any groups on it. Okay? So what is going to happen is, I'm going to attack that. When it attacks that, what you are going to see is a carbon with the Hg and the acetate, yes?
Mhm.
And there were two bonds there.
Yeah.
Still two bonds here. There's a bond there. Is there any formal charge anywhere?
Yes.
On that
the
carbon,
carbon.
there's a plus.
Plus.
There is a formal charge here,
Yeah.
and that formal charge is a plus. This is a carbocation.
Mhm.
So what is going to happen is this mercury is then going to do a bridge that looks like
Mercury near my
How we did with the bromine.
okay. And this will have a positive charge.
Yes.
So what does that look like?
Mercury near my
This looks like a bromonium
Bromonium
ion
ion.
or a chloranium ion.
Chloranium. Yeah.
Okay, this is analogous to that.
Chloranium.
But this is mercury, so they are going to call this
Yeah.
mercuranium ion. How do you like that? So this looks like something that you have already done,
Yes.
yes or no?
Yes.
And what is going to happen now?
You have to come from the bottom.
Something is
That's
going
what
to
it
attack
comes-
this.
Mhm.
I mean, this stuff is in water, yes?
Right.
So what is going to attack is,
H plus.
oxygen.
Oh, yeah. Okay.
what is going to
That's
attack
like it's the
is a water molecule.
Uh-huh.
Which side is it going to attack?
The bottom.
It's Going to attack from the bottom, yes?
Yes.
But which side is it going to attack? This one or this one?
Doesn't
That one.
matter.
It's
Doesn't
going to
matter.
attack the one that,
Most stable,
Most stable.
most positively charged.
yes, the one that is more positively charged, which is the one that has more substitutions on
Right.
it, yes?
Yeah.
Right.
And otherwise, it will not be Markovnikov addition. So here, it
It
doesn't
doesn't
say,
matter. Yeah.
yes?
Right.
It doesn't say. But if this had a hydrogen here, and these were carbons, where would it attack?
Left.
To the left.
It would attack here.
Right.
Okay? But I didn't put anything because I don't want to complicate the mechanism, yes? So what it does is, it's going to attack one of them.
Mm-hmm.
And if it attacks one of them, it's going to produce this thing here.
We're just gonna give it a plus.
It attacked here,
Oh,
the OH is going to be down here.
In this case, it could attract either one equally. It has no
Right.
preference.
Right.
And what is going to happen is HG is gonna be there. Yes or no? Every time you have this mercuronium ion or bromonium ion, what type of attack is this going to be? This is going to be an anti-addition. I want you to notice, this will be an anti-addition up to this point. Okay? Now, the next step, we are not going to do in this class. The next step is one in which that HGOAC
Get
is taken
replaced
away
by
and is
hydrogen.
replaced by hydrogen.
Mhm.
This is the reduction part, which is with sodium borohydride.
Mhm.
Now, the rest of this mechanism has radical behavior. And whenever you have a radical, you lose stereochemistry. Okay?
Mhm.
Yes?
Yeah.
Is that clear?
Yes, sir.
This is why, from the beginning, I don't say this is anti-addition because you lose it in the last step.
Okay.
But up to here, this is anti. Okay? This addition of the water and the mercury, it is anti. Oh, by the way, I put, this is supposed to be a 2 here and a plus, yes?
Yes.
Okay?
Yeah.
Because I asked him the question.
So, what I need for you guys to remember from here is, what I need for you to remember is this. This is what I need for you to remember. The intermediate for this reaction is called mercuronium ion.
I said
And because this is a mercuronium ion, the incoming group is going to be what?
Anti.
Is going to be
anti-addition.
Okay? It's going to be an anti-addition.
Okay, let me get this whole thing now.
Now, let's say we had here, let's say we have here something like this. This mercuronium ion, where can it from? Where can it form from? Can it do a bridge here on the top? Yes or no?
Yes. Yes.
Yes.
Can it do a bridge on the bottom?
Yes.
Yes.
It can do a bridge on the top or a bridge on the bottom. If it does a bridge on the top, if it does a bridge on the top, the attack will be from the other side.
Right.
Yes?
Mhm.
And that may produce an enantiomer that looks like that. But if it does the bridge on the bottom, that may produce an enantiomer that looks like this. Yes or no?
Yes.
And I showed you this when we were doing this, what was it? Hydrohalogenation or?
Yeah.
or
Mhm.
was it
Yeah, hydrogenation, yeah.
Okay, outstanding. So, if the bridge is formed on one side and it gets attacked from one side, it will form one enantiomer. This attack was from the bottom.
The bottom.
This attack was
From
from
the
the
top.
top. So, during this process, you are going to form enantiomers and they will be a racemic mixture. Okay?
Yep.
Nice.
Now, the addition will be anti up to that point, and then after that, I don't know what's gonna happen on this side of the double bond, yes? Most of the time, this side of the double bond, I will not make it chiral. So if this was a hydrogen, I mean, one of these will be a hydrogen, yes? Otherwise, you don't even know where is it gonna be added to. I don't know if you know Markovnikov or not. Okay? Yes?
Wait.
So horizontal tape.
You have not written this yet?
So maybe I'm listening. I was paying attention.
Watch the video. Where are you going, La Vista? You just come from outside and this guy needs to go now. What are you doing?
I got it.
So provide the product of that and show stereochemistry if there is any. So that's what I would do on the test. Provide the product and show stereochemistry if any. Okay, you did it? No? So we redraw this thing, yes? The double bond is supposed to be here, is it not?
No.
Huh?
Nope. I don't know.
I'm saying, okay. The double bond is supposed to be here, yes?
Yes.
Yeah, but.
So we omit writing the double bond. I'm teaching you
Yeah,
how
yeah,
to
yeah,
draw.
yeah, yeah, yeah.
You know how to draw it, then shut up. So here, the double bond is supposed to be here, yes? That's where it was here. There is 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. Between carbon 1 and carbon 2, there was a double bond there. I am not going to write the double bond. What am I going to do? I'm going to write an OH somewhere and an H somewhere else, yes? Because this is a formation of an alcohol. Yes or no?
Yes.
Where is the OH going to go to? The OH is going to go here, yes?
Yep.
Because this is
Markovnikov.
Markovnikov addition. This one here, or this side, has 2 hydrogens, so the next hydrogen is going to go here.
Yep.
So this is going to give you Markovnikov addition. You have to know that if you get Markovnikov addition, and I ask you for stereochemistry, then what do you have to do?
Yeah.
You have to give me R and S. Is this carbon chiral?
Yes.
Yes, it is. So because it's chiral, you gotta give me 2 products, yes?
Okay.
So you are not going to do this like this. You do this on the test, I will take off points. What we are going to do is, we are going to, not very nice. Yes?
Yes.
Plus the enantiomer.
Is that?
Where does the OH go?
Anyway,
I want to put it here on the wedge,
yeah.
and if I put it on the wedge here, this will go on
The
Go
line.
ahead,
the
John.
dash,
The dash, yeah.
okay? I am not asking you what they are, I'm not asking you if they are R or S. But I could ask you on the test, but I don't want to waste your time all throughout the test, because then the test will become very long. Yes or no?
Mm-hmm.
Now, what is the nice thing of oxymercuration, demercuration? What is?
No arrangement.
That there is no
The rearrangement
rearrangement.
of the carbon
Okay.
cation.
When we had before hydration, which was to form an alcohol too, there was rearrangement. So if we had something like this, 1, 2, 3, 4, and we formed a carbocation here, yes? When we added water to this, the H went here, and there was a formation of a carbocation here.
Right.
There was a methyl next to it, there was a methyl
So
shift.
shift, yeah.
And if there wasn't a methyl shift, there was a
Hydride
hydride
shift.
shift. During this reaction, you do not get that.
Yep.
So put no rearrangement. Now, I did a problem before in which I showed you the rearrangement, or I gave you something that was rearranged, and I asked you, oh, what do you think happened here? So, mercury. So, I redraw this thing. Yes? And here's where the double bond used to be at. Now, where is going to be the OH is
Down.
here. But you have to know that this will form enantiomers. And this carbon is chiral. Okay, I don't want you to see this before you do it. I want you to go like this, OH, and then you go 1 group, 2 group, hydrogen, and this one. That's 4 different things on this. So this will be you like that? Yes? This is roughly 109, so where does the OH go? I put the OH here. The other one will go here.
The wedge always goes to the left.
The wedge always goes to the left.
Yeah. Doesn't matter.
I never thought about it, but it doesn't matter. I mean, the wedge means what? The wedge has a meaning, yes?
Yeah.
It means that it is in the front. So wherever you draw it on that side, on this side, it means the same. It's in the front. Well, I happen to draw them both on the left. That is just coincidence. Okay, so hydroboration oxidation. Let's do a couple of things about this mechanism. Okay. Now this hydroboration oxidation mechanism is somewhat heavy, yes?